Episode 78. Long Listen, Mastering the Art of Prompt Engineering with Google's AI Guide for Marketers.
The AI 6 Podcast with Joanne Sweeney.
Welcome back to the AI 6 Podcast. I'm Joanne Sweeney. Today's episode is a Long Listen special. I decided to do something a little bit different. I took Google's prompt engineering guide, the one that's making waves across marketing and tech circles, and ran it through Notebook LM, Google's own AI-powered research. Then I asked it to have a deep dive discussion with me, not just a summary, but a real conversation about the key points, how marketers can use it, and how prompt engineering is becoming a critical skill in our industry. So here you go, have a listen, and another great example of how to use AI.
Welcome to the deep dive. Today we're getting into prompt engineering, which is, basically how we talk to large language models, LLMs, to get them to do what we want.
Right. Anyone can type something into the box.
Sure, anyone can write a prompt. But getting really effective prompts, that's a bit more complex, isn't it?
Absolutely. It's definitely more than just like asking a question. You've got to think about the specific model you're using, Gemini, maybe something else.
Right.
The huge amount of data it learned from, those configurations you can often tweak.
The settings.
Yeah, the settings. And just the exact way you phrase your request, it all makes a difference. It's really an iterative thing you learn by doing.
Exactly. And that's what this deep dive is all about. We've gone through a pretty detailed white paper on this.
Yeah, it's thorough.
And we want to pull out the core techniques so that you can understand how to get more accurate, more meaningful responses from these AIs.
And we're focusing mainly on prompting models directly, right? Like using Gemini and Vertex AI or through an API.
Exactly.
Yeah.
Because that lets you access those important configuration options, like temperature, which we'll definitely get into.
Okay, let's do it. Where do we start?
Well, maybe the fundamentals. How these things even work.
Good idea. So an LLM, at its core, it's basically a prediction engine.
Predicting what comes next.
Exactly. Based on all the text it's been trained on, it calculates the probability of the next word, or part of a word, a token.
Right, tokens.
So prompt engineering is really the art and science of designing these input prompts, your text, to skillfully guide that prediction process.
To get the output you actually want.
Precisely. And that involves thinking about prompt length, the writing style, the structure, how you put it all together.
And the range of tasks is pretty amazing. The source mentioned things like text summarization, pulling out specific info.
Information extraction, Q&A, classifying text.
Translation too, right? Languages and code.
Yep, language translation, code translation, generating code, documenting code, even complex reasoning.
Wow. Okay, so lots of possibilities. But you mentioned earlier the model choice matters.
Hugely. A prompt that's perfect for Gemini might need some tweaking for, say, GPT or Claude or Llama.
So you might need to optimize for the specific model.
Often, yes. And it's not just the words in the prompt. The white paper really stresses how crucial configuring the LLM's output is.
Okay, so let's get into those configurations.
Yeah.
This is where you fine-tune the output.
Exactly. First up, output length.
Just how much text it spits out.
Basically, yeah. You set a limit on the maximum number of tokens it generates. Now, cutting the limit doesn't magically make the answer shorter and better.
Right, it just stops predicting.
It just stops. But this is important for certain techniques like React, which we'll probably cover later. And of course, shorter outputs mean less computation.
Faster, cheaper.
Right. Less energy, faster speed, lower cost.
Okay, so controlling quantity. What else can we control?
The other big one is sampling controls. This gets into how the LLM chooses the next token. It calculates probabilities for all possible next tokens, then it samples based on those probabilities. And the key settings here are temperature, top K, and top P.
Right, I've heard of temperature. Controls randomness.
You got it. Think of it like a creativity knob. Low temperature, the model plays it safe, picks the most likely predictable tokens. Good for facts, deterministic answers.
Like temperature 0.
Temperature 0 is what they call greedy decoding. It always picks the single most probable token.
Right.
No randomness at all.
Okay, so low temp, predictable. What about high temperature?
Crank it up and you get more randomness. The model is more likely to pick less common, maybe more surprising tokens.
More creative, maybe unexpected.
Exactly. Can be great for brainstorming, writing stories, but if you go too high, it might just become incoherent.
A bit nonsensical.
Yeah. The white paper actually has a nice analogy for Gemini's temperature. It relates to the confidence of the underlying model, like in the softmax function output. Low temp is high confidence in one answer.
Interesting. Okay, it's temperature. Now, top K and top P, also about randomness.
They are, but they work a bit differently. They restrict which tokens the model even considers sampling from based on probability.
How so?
Top K is simple. Only consider the top K most likely tokens. So if K is 10, it only looks at the 10 most probable next tokens.
Higher K means more options.
Right. More potential for diversity. K of 1 is greedy decoding again, only the top choice.
You have top P.
Top P, or nucleus sampling, is slightly more dynamic. Instead of a fixed number, K, it selects the smallest set of top tokens whose cumulative probability adds up to at least P. P is a value between 0 and 1.
Huh. So it could be many tokens if probabilities are spread out, or just a few if one is very likely.
Exactly. It adapts based on the probability distribution.
So top K is a fixed count, top P is a probability budget.
Good way to put it. And you often need to experiment to see which one, or maybe a combination, works best for your specific task.
How do they work together? Like if I said temperature, top K, and top P.
Good question. The way Vertex Studio handles it, according to the source, is first it finds the tokens that meet both the top K and top P criteria.
Okay, a filtered list.
Then it applies a temperature sampling to that filtered list.
Got it. What if I only set one, like just top K?
Then it just uses that filter. If no temperature is available, it would likely just pick randomly from the tokens that pass the K or P filter.
Okay, step-by-step filtering and sampling. What about those extreme settings you mentioned, like temp 0 or P close to 1?
Right. Temp 0 always gives the same answer, ignores KP. High temp makes KP more dominant. Top K of 1 is always greedy. High top K lets almost anything through. Top P near 0 is basically greedy too. Top P of 1 considers everything.
So they interact in sometimes complex ways. Do you have any, suggested starting points?
Yeah, the paper offers some guidelines for a balance of adherence and some creativity. Maybe temperature around 0.2, top P 0.95, top K 30.
Okay.
Want more creativity? Try bumping temp up towards 0.9, top P near 0.99, top K around 40.
And less creativity.
Maybe 10.1, top P 0.9, top K 20. And like we said, if there's really only one right answer, like solving a math problem, temp 0 is often the way to go.
Those are helpful benchmarks, but there's a balance to strike, right?
No.
Too much freedom isn't always good.
Definitely. If you set temperature, K and P really high and allow lots of output tokens, you risk getting responses that are just rambling or irrelevant. Finding that sweet spot is key.
Okay, this is great. We understand the basics and the configuration knobs. Let's get into the specific prompting techniques the white paper covers.
Right. How to actually structure the prompts. The simplest is general prompting, or what's often called zero-shot prompting.
Zero shot. Sounds like you're not giving it much help.
Pretty much. Zero-shot means you give the LLM the task description and maybe the input text like a question or the start of a story, but no examples of the desired output.
So it has to figure it out just from the instruction.
Exactly. Zero examples provided.
Can you give an example?
Sure. The paper uses movie review classification, goal.classify as positive, neutral, or negative, model.Gemini Pro, temperature, very low, 0.1, because no creativity needed, token limit, 5, just for the label. Top K wasn't applicable, top P was default 1. The prompt was basically, classify movie reviews as positive, neutral, or negative. Review text here, sentiment.
And the example review is that one about her.
Yeah, the one calling it disturbing, but also a masterpiece.
Tricky one.
A bit, but the model outputted positive.
And it worked, even with zero shots. Likely picked up on masterpiece.
Probably. So zero-shot works for simpler, well-understood tasks. But what if it doesn't?
Then you need example.
Exactly. That leads us to one-shot and few-shot prompting.
Okay, what's the difference?
One-shot means you provide one example, one input, and its corresponding desired output in the prompt. Like, here's how I did it once, now you do this new one.
Got it. And few shot.
Few-shot means providing multiple examples. This gives the model a clearer pattern to follow. The more examples, the better it usually understands the desired structure or style.
Like showing your work multiple times. How many examples are few?
It varies. Depends on task complexity, example quality, the model itself, input limits. But the paper suggests 3 to 5 examples is a pretty common rule of thumb.
Okay, 3 to 5 examples. Can we see a few shot example?
Definitely. The paper has a good one. Parsing pizza orders into JSON format. Again, low temperature, 0.1, but a higher token limit, 250, because JSON can be longer.
Right.
The prompt starts with the instruction, parse dot into valid JSON, and then gives several example blocks. Each shows a sample order, like medium pepperoni, and the correct JSON output.
And they included tricky ones.
Yeah, like a half and half pizza order, which is a good edge case. Then, after all the examples, it gives the new order to be parsed.
So the examples teach the format and handle variations.
Exactly. And the quality of those examples is critical. They need to be relevant, diverse, cover edge cases if possible, be accurate and well written. Any errors in your examples can really throw the model off.
Makes sense. Garbage in, garbage out, even for examples.
Yeah.
Okay, so we have 0 shot, 1 shot, few shot. Now, the paper talks about system, contextual, and role prompting. Sounds like more ways to guide it.
They are. Think of them as ways to frame the interaction. System prompting sets the overall, operating parameters or purpose, the big picture, like you are a translator, or output must be JSON.
Okay, the ground rules.
Contextual prompting provides specific background info relevant right now for the current task, helps it understand the immediate situation.
Like giving it the backstory for this specific conversation.
Exactly. And role prompting assigns the LLM a specific persona or identity, like you are a sarcastic teenager or you are an expert astrophysicist. This shapes the tone, style, and knowledge it draws upon.
Could these overlap? Like, couldn't a system prompt assign a role?
For sure there's overlap. A system prompt could define a role. But it's useful to think about their main focus: system for fundamental rules capabilities, context for immediate task details, and role for the output's personality and style.
Okay, distinctions are helpful. Let's look at system prompting first. What's the big win there?
System prompts are great for enforcing specific output requirements, like formatting. The paper shows the movie review example again, but adds a system instruction: only return the label in uppercase.
And it worked, even with higher temperature.
Yep. They used temp 1, top K 40, top P 0.8, allowing more freedom in reasoning, but the system prompt forced the output format. Positive. So it's good for strict rules.
What about that JSON example? That used the system prompt too, right?
Yes. Another system prompt example showed requesting JSON output for the movie review. The prompt explicitly said, return valid JSON, and even provided the JSON schema the expected fields and types.
Like sentiment, positive movie name.
Exactly. The benefit of JSON is huge for data extraction. It's structured, machine-readable, limits hallucination by enforcing a format, and you can even use system prompts for safety, like adding, be respectful.
Very useful.
Oh.
Okay, let's switch to role prompting, assigning a persona.
Yeah, this is about tapping into the LLM's knowledge by asking it to act like an expert or a specific character, like a book editor, a teacher, a travel guide.
How does that help?
It guides the model to access information and adopt a tone consistent with that role. The paper has an example. Act as a travel guide for Amsterdam. Provide 3 museum suggestions. The model then gives relevant, guide-like recommendations.
So the role provides a blueprint for style and expertise.
Exactly. And you can combine it with style instructions. The paper lists styles like confrontational, descriptive, formal, humorous.
Ooh, humorous travel guide.
They show that too, for Manhattan. The prompt asks for a travel guide role and a humorous style. The resulting suggestions are funny.
Fun. Okay, that leaves contextual prompting, giving background info.
Right. This is about making sure the LLM understands the specifics of the current situation or request. Providing context helps it generate relevant and accurate responses quickly.
Like setting the scene.
Precisely. The example is asking for blog article ideas. The context given is, you are writing for a blog about retro 80s arcade video games.
So the suggestions are all about Pac-Man and Donkey Kong, not modern stuff.
Exactly. The context grounds the response. Context is king for relevance.
Okay, those are foundational. Now for some more advanced stuff. Step back prompting. Sounds like taking a breather.
Sort of. The idea is, before asking the specific complex question, you first ask the LLM a more general related question.
Why?
It forces the LLM to first activate broader background knowledge and maybe engage in more abstract reasoning before tackling the specific problem. You then use the answer to that general question as context for the specific one.
So prime the pump with general knowledge first.
Yeah. It can lead to more insightful, accurate answers for the specific task. It uses more of the knowledge stored in the LLM's parameters. And the paper suggests it might even help mitigate biases by focusing on general principles first.
Interesting. How does it look in practice?
They compare a direct prompt asking for a challenging FPS-level storyline, which gives a generic answer at high temp, with the step-back approach. First, the step-back prompt. Based on popular FPS games, what are 5 fictional key settings? The LLM lists things like abandoned military base, cyberpunk city, underwater research facility.
Got it. General settings.
Then they take one of those underwater research facility and plug it into the original storyline prompt as context.
And the result.
A much more specific, engaging storyline tailored to that underwater setting. The step back provided crucial grounding.
Clever. Okay, next up. Chain of thought, or COT. Heard a lot about this one. Improving reasoning.
That's the goal. COT prompting encourages the LLM to generate intermediate reasoning steps to basically think out loud before giving the final answer.
Like showing your work in math class.
Exactly. By breaking down the problem, especially complex ones, it often leads to more accurate results. It's often combined with few-shot examples.
What are the advantages?
It's pretty easy to implement, works well with many existing LLMs, offers interpretability. You can see how it got the answer.
Which is great for debugging.
Right. And it seems to make prompts more robust across different model versions.
Any downsides?
The main one is cost and time. Generating all those reasoning steps uses more tokens, so it's computationally more expensive and takes longer.
Makes sense. Can we see an example?
Sure. The paper shows a simple math-age calculation problem. A direct prompt gets the wrong answer. But then they just add, let's think step by step, to the prompt that's zero-shot CT.
Yeah.
And the model then outputs the steps. Calculate the sister's current age, then the person's age in 7 years, and it gets the correct answer.
Just by asking to think step by step.
Yep. They also show single-shot CT, where they provide one fully worked-out example before the actual problem, which guides it even more.
Where's key most useful?
The paper mentions code generation, breaking down the request, creating synthetic data. Really any task where you'd naturally talk through the steps to solve it.
Okay, thinking step by step helps accuracy. Now, self-consistency, how does that relate?
Self-consistency builds on COT. While Co improves reasoning, it often uses that greedy approach, picking the single best step. Self-consistency says, let's try multiple different reasoning paths and see which answer comes up most often.
Like getting a second, third, and fourth opinion from the same AI.
Exactly. You generate several different chains of thought for the same prompt, usually by using a higher temperature to encourage variety, extract the final answer from each, and then choose the answer that appears most frequently, majority vote.
So it improves reliability, especially for ambiguous problems.
That's the idea. It gives you more confidence in the answer, but again, it's costly because you're running the prompt multiple times.
Can you illustrate?
The paper uses an email classification task, important or not important. The email's tone is a bit tricky, maybe sarcastic. They run the same zero-shot QWERTY prompt multiple times.
And get different answers.
They show 3 runs with different reasoning paths and slightly different conclusions. By generating many quotas and taking the majority vote, say important comes up most often, you get a more robust answer.
Fascinating. Okay, what about tree of thoughts? TT. Sounds even more complex.
It is a generalization of COT. Instead of just one chain, 2T allows the LLM to explore multiple different reasoning paths simultaneously, like branches on a tree.
So it can explore different ideas in parallel.
Kind of. It maintains a tree where each thought is an intermediate step. It can branch out, evaluate different paths, maybe backtrack if one looks unpromising. It's designed for complex problems needing exploration. The paper has a diagram.
Sounds powerful. Probably needs more setup. Okay, next is react, reason, and act. This brings external tools into play.
Exactly. React is a paradigm that lets the LLM combine its reasoning abilities with actions, like using a search engine or running code. It moves towards creating AI agents that can interact with the world.
How does it mimic human problem solving?
We think about what we need, maybe look something up. Act, use that info to think more, reason, maybe act again. React follows a similar loop. Thought, action, observation, thought, action.
So the LLM decides it needs info, performs a search, action, gets results, observation, thinks about them, plans the next action.
Precisely. Until it reaches a solution. But this requires code integration, not just prompting.
Right. The paper showed code using LangChain, Vertex AI, and a Google search tool.
Yeah, you need something like that, plus API keys. The example task was finding the total number of children of Metallica band members.
How did React tackle that?
The output showed it reasoning, I need the band members. Action. Search Google for Metallica members. Observation. Got a list? Thought. Now I need children for each member. Action. Search James Hetfield children. Observation. Got 3. Thought. Okay, next member.
Wow, so it chained multiple searches based on its reasoning.
Yeah, 5 searches in total, scraping info, reasoning about the next step until it got the final answer. 10 children. It involves managing the prompt history and instructing the model on how to use the tools.
Very cool. Okay, let's shift again. Automatic prompt engineering, APE. AI writing prompts for AI.
You got it. It's basically using one LLM to generate and evaluate potential prompts for another LLM task. A prompt to write prompts.
How does that work? Is it effective?
The process is 1. Prompt an LLM to generate many variations of a prompt for your goal. G, different ways a customer might order a t-shirt for chatbot training. 2. Evaluate these generated prompts using some metric, like how well the resulting outputs match desired outputs. 3. Select the best performing prompt.
So you leverage the LLM's own language ability to find better ways to ask things.
Exactly. It can discover phrasing you might not have thought of.
Clever meta-level prompting. Okay, let's talk specifically about code prompting. Gemini handles text, but that includes code.
Right. You prompt it with text to get code, explain code, etc. Vertex AI Studio is good for testing these.
So first, prompts for writing code.
LLMs can be a huge help here. Speeds up development. The paper gives an example, needing a bash script to rename hundreds of files by adding draft at the start. They prompted Gemini Pro, low temp, again for predictability, to write this script. It generated working bash code, complete with comments explaining it.
Nice, but you need to check it, right?
Always. Crucial point. LLMs might repeat patterns from training data without true understanding. Read it, test it thoroughly. The paper shows testing the script.
Good advice. What about explaining code?
Also very useful. Take someone else's code or your own old code, remove comments, and ask the LLM to explain it line by line. The paper shows this with the bash script. It gives a detailed explanation.
Great for understanding legacy code or libraries and translating code.
Yep. Scenario. Maybe that bash script needs to be a Python app with a UI. Prompt the LLM. Translate this bash code to Python.
And it does it.
The example shows it generating equivalent Python code, again with comments, and again the advice is read, review, test the translation.
Makes sense. Finally, debugging and reviewing code.
Super powerful. The paper shows taking the Python script, manually introducing an error, like using to uppercase instead of dot mistake. Then they give the broken code and the Python error message traceback to the LLM prompt. Debug this code using the traceback and suggest improvements.
What did it do?
It correctly identified the name error, provided the fix, .upper, and suggested other improvements like handling file extensions, using f-strings, adding error handling, try.accept. It even provided the improved code.
Wow, that's like an AI code review assistant. Amazing. Okay, one last quick thing before best practices. Multimodal prompting.
Just a brief mention, it means using inputs beyond just text images, audio, code, text, all together depending on the model's capabilities. Think asking questions about an image you upload. It opens up way more possibilities.
Another huge area. Okay, let's summarize with the best practices for prompt engineering from the white paper. What's number one?
Provide examples. We keep coming back to this. One shot, few shot, showing the model what you want is often the most effective way to improve accuracy, style, format, everything. Show, don't just tell.
Got it. Examples are key. What else?
Design with simplicity. Keep prompts clear, concise, avoid jargon, easy for you and the model to understand. Be direct.
Simple and clear. Next.
Be specific about the output. Don't make the LLM guess. Tell it the format, the length, the key information you need. More specifics, better focus.
Specificity helps. What about instructions versus constraints?
Right. Use instructions over constraints. Tell the model what to do, instructions, rather than just what not to do, constraints. Positive framing seems to work better. Instructions guide towards the goal. Constraints just block paths. Use constraints when needed, safety, strict format, but prioritize positive instructions.
Focus on the positive goal. Good tip. What else?
Control the max token length, either in settings or in the prompt. Explain in under 50 words. Use variables and prompts for reusability, especially in applications, makes them dynamic and easier to manage.
Variables are smart. And experimentation.
Crucial. Experiment with input formats and writing styles. Try questions, statements, instructions, change wording. See what works best for your model and task. For few-shot classification, mix up the classes in your examples to avoid order bias.
Keep trying things and adapt.
Yes, adapt to model updates. Models change. Test new versions. Adjust prompts to leverage new capabilities. Tools like Vertex AI Studio help manage versions. Also, experiment with output formats like JSON for structured data tasks.
Stay current and work together.
Yeah, experiment together with other prompt engineers. Get different perspectives. Share what works. For COTI, make sure the answer follows the reasoning and is easy to extract. And usually use Tempa for SOTI.
Collaboration helps. And finally, Documentation.
Absolutely critical. Document the various prompt attempts. Track the prompt, model, settings, output, whether it worked. Use a spreadsheet maybe. The paper has a template. This helps you learn over time. Once a prompt is good, save it properly. Prompt engineering is iterative. Craft, test, analyze, document, refine, repeat.
Fantastic summary. It really is an iterative process, isn't it?
Yeah.
Craft, test, analyze, document, refine.
Exactly. It's a valuable skill. We've covered a lot. Zero shot, few shot, system, role, contextual, step back, SUTO, self-consistency, 2T, React, APE.
The whole toolkit. And mastering these, along with the best practices, really can help you, the listener, get much better results from LLMs.
Absolutely. So the main message is start experimenting. Try these techniques. See what works for you. Keep learning because this field moves fast.
Definitely. And maybe a final thought to leave everyone with. As we get better at talking to AI, at guiding it precisely with language, how is that going to change things? Not just tech, but how we learn, how we create, how we solve problems.
Yeah, what new possibilities open up when we become truly fluent in speaking to AI? It's fascinating to think about.
It really is. Thanks for taking this deep dive with us today.
The AI 6 Podcast with Joanne Sweeney.